All right, so on step 4, we're going to take those coefficients and we're going to simplify them. So that means that we're going to take 25 and 625, and we're going to divide them by the greatest common factor. So 25 divided by 25 is going to give me 1. And I'm going to write everything the same in the top. In the bottom, 625 divided by 25 is going to give me 25. And then I'm going to write everything the same in the bottom. Okay. The reason why I'm not writing that 1 in the top is because it's just unnecessary, and normally you're not going to see that as in your final answer. Okay, what does step 5 say for the instructions? What does step 5 say? On the left-hand side. Okay, so what that means is we're going to look at all of these negative exponents, and we know from our negative exponent rule, that if it's a negative, we can switch it across the division line, right? So what we're going to do is write everything else that's not a negative the same, and then we're going to switch those negatives to be positive. Okay, so that's going to give me y to the 16th, z to the 4th, c to the 4th, x to the 12th, z to the 44th, over 25, y to the 2nd, x to the 20th. So all I've done is everything that was yellow over here, I flipped it on the other side of the division line, and everything else stayed the same. That's step 5. Step 6, it says to combine all your bases, right? Okay, so this is going to be a combination of the product rule as well as the quotient rule. Okay, so this next step is going to be the product rule and the quotient rule. Okay, so we're going to look at our exponents. If they are the same and they're on the same side of the division line, then we're going to use the product rule. That means that we're going to add those exponents together. So that's going to give me z to the 48th power. Okay? We're also going to look at the quotient rule. So we see that there's a 16 and a 2 down at the bottom with the base of y. So 16 minus 2 is going to give me y to the 14th power. And we're going to put that in the top. And the last piece is that we have this x to the 12th and x to the 20th. So 12 minus 20 is going to give me x to the 8th. And we're going to leave this 25 in the denominator. So one thing that I noticed on your test yesterday was really the fact that we're not substituting this stuff into our graphing calculators correctly. So this is the back of page 2. Back of page 2. All right. So with that being said, this is the first problem that's on your paper. Okay. So if I were to identify this graph, in order to put it in my graphing calculator, this is how I have to type it in. You see this stuff right here, this colorful stuff up on the board? Okay. The reason why I have so many parentheses is if I just type this in 3 divided by x minus 1 plus 1 with no parentheses, what I'm telling my calculator is this actually. I'm saying 3 divided by x minus 1 plus 1. That is what I'm telling my calculator if I don't use these parentheses. Okay? So here, what's happening is we're saying take this number, divide it by this polynomial on the bottom, then take that whole fraction, then add it to 1. And that's what this function actually says. So when you graph this, you need to make sure that you are using the correct way to put it in. Also, for domain, and this wasn't on your test, but I'm sure you'll see it on your final exam. for domain, you're always going to have all real numbers, but you're going to say where x cannot equal the vertical asymptotes and the wholes. If you didn't know that, I would write that down. So for domain, for rational functions, you're saying from negative infinity to positive infinity, where x cannot equal whatever your vertical asymptote is and whatever your wholes are. Okay? I would just put it as a side note. I'd put it as like a little star at the top of my paper. For range, we're on the back of page 2. For range, what I would put is from negative infinity to positive infinity. However, there's going to be some points, if you're talking about rationals, there's going to be some point that you're going to reach for your horizontal asymptote, okay? So this is going to be from negative infinity to your horizontal asymptote, and you're probably going to have from your horizontal asymptote to positive infinity, okay? That's another way to write your range. Okay, so from negative infinity to your horizontal asymptote, so whatever that is, and from your horizontal asymptote to positive infinity, that's what your range is, because there's going to be like that cutoff at your horizontal asymptote. There's not going to be a number right there. Okay? Questions on those? So what I want you to do is when you plug these in to your graphing calculator, the difference between discontinuous and continuous, that is another conversation that we need to have. Discontinuous means that it's not continuous, right? That means you have to pick up your pencil and then place it back on your paper in order. That's not how you spell continuous. That's okay. All right, so you're going to have to pick up your pencil and then draw the rest of your graph. Or this means that you have a whole or a vertical asymptote. That's what discontinuous is. If you don't have those, then it's a continuous function. Continuous functions are like linear functions. Continuous functions are linear functions, quadratic functions, cubic functions. It's all the stuff that we've already been studying. Rational functions is where we start getting discontinuous. Okay? We're going to see that more with our radicals when we come back for next semester. Okay?